So we are live now. So let me share my screen.
Excuse me, sir.
Yes.
So actually, I'm still doing the week 0 of part 3. Like I'm
Uh,
doing it. So can I able to like understand this week 1?
yes, yes, yes. So week zero is just revision of stats one course. Okay. So you can
Like sir, but
simply.
some things are there like but knowledge trials are like
Yeah. So it's a
yeah,
no. So it will cover all the concepts of stats one, and there are some other maybe negative binomial and on a bit
yeah,
one step higher than stats one course. So
yeah.
you can go through that. But thing is that on the upcoming Wednesday you have the due date of week 1 assignment, right?
Yes,
So it would be great. You can start watching content of week 1, and in between, whenever you will get time, you can go through the week 0 content. Okay.
yeah.
Okay. All right. So let me share my screen, and we'll try to discuss the
Sir,
concepts
I
of.
have another doubt.
Hmm?
Sir, there is a notes as well that like lecture transcript the portal videos. So it is mandatory to take the notes
It's up to you whether you are taking those notes or you are preparing your on your own notes. Okay.
because of that will take too much time to complete the lectures. There's a lot of content inside the portal.
Correct. So you can simply watch the content, and then you can refer the lecture PPTs and slides. Okay.
Yeah, sir. Thank you, sir.
Okay.
Uh, Prashant sir, one suggestion, sir.
Hmm?
Uh, Sir, can we take this all the doubts that is not related to the syllabus and at the end? Right now, can we start with the
Yeah, that
syllabus?
should be the basic agenda. I think
Yeah,
we
yeah.
have these kind of things already. We had discussed in stats one course. Like whenever you have any general doubts, we can discuss at the end. Okay, because
Yes,
lots of people
yes.
are waiting. Okay, no worries. So let me start the things. So first we will okay. So in stats one, I think in week 9 we started. What is the random variable? Then we moved on. Okay, like PMF of if okay. First of all, what is the random variable? And we saw there were two kind of random variable. First one discrete, and another one is continuous, right? So we will see more about continuous from week 4 onwards. So now we will focus on discrete itself. Okay. So in discrete, if I have x as a discrete random variable, okay, so it's a request to everyone. If you do not have anything, okay, so please mute yourself. Okay, so if I have discrete random variable, right? So if I want to know the probabilistic behavior of like whatever the random variable x is going to take for each values, okay, so that is something. Okay, maybe you can recall PMF, right? Probability mass function. Yes or no? Everyone can
Yes,
recall
sir.
this.
Yes, sir. Yes,
Okay.
sir.
And what was this probability mass function? It's just nothing but probabilistic behavior, right? So probabilistic behavior at each value of x. So what I mean by probabilistic behavior at each value of x, suppose my random variable x is taking value, let's say x1, x2 up to xn, for example. Since this is the discrete, I can count. Okay. Then probabilistic behavior means what is the probability when x1 is this x is taking value x1. Let's say this is p1. For x2, this is p2. For xn, this is pn, for example. Okay. So far so good. So this was the PMF, right? And there were two major property for being a valid PMF. What was that? All the probabilities should be greater or equal to 0. Yes or no? Right?
Yes, sir.
Second one was summation of all the probability should be
Would
equal
be
to
equals to
1.
one.
Correct? So these two were the major property of being a valid probability mass function, right? So this was for single random variable. Okay. Now we will see, uh, you know, uh, a, a step ahead means we will see what if you have two random variables. Okay, so what is this? If I will say what is this? X is taking value x1, x2, xn. What is this? This is range of x. Yes or no?
Yes, sir.
Range of x is
Yes,
this one,
sir.
right? X is taking this value, so this I will call as a range of x, right? Okay, so far you are able to recall this.
Yes, sir.
Yes, sir.
No. Okay,
Yes, sir.
great. Now we will move similar with the, I mean, we will use this concept, okay, for if what if you have two random variable, okay. So if I have two random variables, okay, so if you have two random variable, there will be two to three things. First thing, we will see under two random variable what is the joint, okay, joint probability mass function, okay, and then we will discuss what is the marginal PMF. PMF stands for probability mass function. And then since we have two random variable, I will see what is the conditional PMF. Okay. So majorly we will see these three things. Okay. Let's start the basic definition of this probability mass function. I mean definition of joint probability mass function. Since I have two random variable, I will refer this as a joint probability mass function. So how I can define? So suppose I'm saying, okay, let me write the first thing. Let me write some definition. Okay. Suppose I'm saying, suppose, okay. So how, okay, let me write here joint probability mass functions. Okay. How I can define the joint probability mass function. Okay. So first of all, let me write and then I will explain the meaning of notation. So I will x, y, okay, T1 comma T2 as this means probability x equal to T1 and y equal to T2. Okay, where so this T1 will belong to T of x and T2 belongs to T of y.
Why?
Let's try to understand what is the meaning of the notation. So this means I'm interested the joint probability mass function of x and y when x is taking value T1 and y is taking value T2. Okay, so you can see T1 belongs to Tx, right? So what is the meaning of Tx? What okay, can you guess what is the role of Tx here?
Random
It's a
variables.
range, no?
Range. Okay,
Range.
Range.
so here Tx will represent range of random variable x, okay, and Ty represents range of random variable y. So you can see if if you will relate with single random variable, so what is the x? X is a random variable and it is taking x1, x2, xn. So here you can say Tx is this one. So I can here simply define Tx is what? X1, x2 up to xn. Okay, now since I have two random variable, so this T1 will belongs to Tx. So T1 is one of the value. So you can define, let's say Tx, I can define something like that. Let's say Tx will take value T1. Let's say some T1 dash or T1 double dash or something like that. Okay, something there should be some count. Let's say T1 n. Okay, these are some dummy values. So let's say Ty, T2, T2 dash, T2 double dash, and something, let's say T2 and something. Okay, these are some values. So you can relate. So this T1 belongs to range of x and T2 belongs to range of y. Okay, so this is something I will denote the joint probability mass function. Some rough idea is okay.
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
Now
Yes,
Yes.
sir.
let's
Yes, sir.
let's try to understand with an example. Okay. So suppose I have one example and I have defined I have two random variable, let's say x, y and t1 comma t2. Okay. So how I can define this joint probability mass function? First of all, let's try to okay. Suppose I'm saying I have x here and y here. Okay, how to make the joint probability like joint PMF table. Okay, if you have a single random variable, right, so you can simply denote x here, x1 x2 up to xn, and then you can simply write the probabilities corresponding to each values, right? Then this will be your PMF table, right, for a discrete random variable. Yes or no? Right? If I have two
Yes, sir.
random variable, okay, so it I have to make a table. How we can make a table? So let's say, so suppose x is taking value 0 and 1. Okay, this is, I'm saying here tx is 0 comma 1, and let's say ty is also 0 comma 1, just for simplicity. So here y will take 0 and 1. Okay, suppose what are all the probabilities, let's say, suppose I'm saying for 0 0 probability is 1 by 4, for this again 1 by 4, for this 1 by 4, for this 1 by 4. Okay, so one thing need to check here. Okay, so what is the what are the properties of being a valid probability mass function?
Should be between
The
0 and 1.
summation
Each
will be
entry is
1,
between 0 and 1, and sum of
and
all
each
entries equals
probability
1.
must be greater than
Correct.
1.
So you can see all the
Yes, sir.
probabilities are greater or equal to 0. I mean,
Yes, sir.
0 and between 0
Yes.
and
Between
1.
0 and 1,
And
And
if you will
all the
add,
sum of
probability
all
summation is
is
1.
equal to 1.
correct? So 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, which is 4 by 4, which is 1.
Yes, sir.
Okay, this is valid PMF or not?
Yes, sir.
Okay,
Valid.
so this is something you can make joint PMF table. Okay,
So here, like you have taken 1 by 4 randomly only. Like,
yeah, I took just randomly.
okay.
We can cross verify with let me take one example. It's very standard example. Let's say I'm going to toss a coin twice. Okay, okay, so here okay, first of all, one more thing, let me clarify here. So you can see this part. This part is for random variable x. Okay, x, and what are the possible values x is taking. Okay, and this part, this vertical part, you can say this is for y. So here it means this is for y, and y is taking value 0 and 1, and here x is taking value 0 and 1. Okay, what is this part 1 by 4? This means fxy 0 comma 0, right?
Yes, sir.
Yes, sir.
Correct.
Yes, sir.
Yes,
And
sir.
what is this part? This
0,
part
comma
means
1.
0,
0
0,
comma
comma
1 or 1 comma
1
0,
comma
1
0.
comma 0.
right? Are you okay? Are you getting this point? What is
Yes,
Yes.
this?
sir.
This is probability
0
x
comma
equal
1.
to 0,
0,
y
comma
equal
1.
to, and this part is probability x
1,
equal
comma
to
1.
1 and
1
y
comma
equal to 1,
1.
right? Okay. So let me take this example. Suppose I'm going to toss unbiased coin, or let's say fair coin, 2 times. Okay. And suppose I have defined xi will take 1 if my ith coin, okay, I mean
Is
ith
tail.
coin, let's say I'm going to toss a single coin. So it would be great if I will write if ith toss, okay, is head. Okay, and xi will take value 0 if ith toss is tail. Okay, now, so what is the possible values of I can take here? 1 and 2? Yes or no?
Yes.
Yes, sir.
Right? Because you are
2
tossing coin
dots.
2 times, right? Okay, so just tell
Yes,
me the
sir.
value. Suppose I'm writing fx1 x2 0 comma 0. So what is the meaning of this? This means I can write x1 is taking value 0 and x2 is taking value
0.
yes or no?
0.
Right. So this means, okay, this you can relate this. X1 is taking value 0 and x2 is taking value 0. So what is the probability that x1 will take value, since it's a fair coin and it's independent also, right? Yes or no?
Yes, sir.
Because
Yes.
there,
Yeah.
there will not be
Yes,
any
sir.
Yes, sir.
dependency on tossing a coin. So can I write what is the probability of x1? It will take value 0, or you can
1
say
by 2.
1 by 2.
correct.
1 by 2.
So 1 by 2 into
Into
again
1 by 2.
this is 1 by 4,
Yes,
right?
Yes,
sir.
sir.
If I will write fx1 x2 0 comma 1, then what is the meaning of this? So this means x1
x1
is
is equal to
take
0.
0 and
And
x2
x2 is
equal
1.
to, right? Again half into half equal to,
1 by 4. 1
right?
by 4.
If I will write fx1 x2 1 comma 0, so what is the meaning of this? Fx1 equal to 1
Ex is 1
and
and
x2
ex2
equal
is
to
2
0.
equal to 0.
0.
Again, okay, why I'm writing half
Okay.
into half? Anyone? Any guess?
Probability.
Half
Probability of
Sir,
probability
getting
of
head and tail is
1
getting
1 by
head.
2.
Getting a
1
head and
to
a tail
tail.
is
So, okay, why I'm able to split this part?
because there is
Uh,
and between
Both
them.
those are independent.
Independent.
Multiple.
Okay.
Yeah,
Right.
independent.
So this means x1 equal to 1 and x2 equal to 1, and again it will be 1 by 2 into 1 by 2, 1 by 4. Okay. So you can see
Yes,
the
sir.
similar table I have created, right? For 0 and 1. You can relate this as a x1 and let's say this is x2. Now, is it fine for every possible joint probability you are getting 1 by 4, 1 by 4, 1
Yes,
by
sir.
4, right?
Yes, sir.
yes, sir.
Okay,
Yes, sir.
let's take one more example and then we will see, how to create joint this PMF table. So, okay, let me write one example. Okay, suppose I'm saying I have defined joint probability mass function for two discrete random variable as 1 by 27 times 2x plus y, and range of this x and y is tx is 0 1 2 and ty is again 0 1 and 2. Okay, now so thing is that suppose okay, first of all we will create joint probability mass, I mean joint PMF table, and then we will try to identify some question from here. Okay, so first thing is there. So let's start. So this I can write as a x and this I can write as a y. Okay. So what is the possible values x is taking? 0, 1 and 2, right? Yeah.
Yes.
This is the
Yes,
range
sir.
of x, right?
Yes, sir.
For y,
Yes, sir.
Yes.
0,
0,
1.
1,
0,
1,
1, 2.
2.
right? Now, so how will you find the value for 0 and 0? What is the meaning of this part? Okay, what we have to do basically. So this means this
Sir, we have to put the values of x and y
okay. So
in the
this
from
means
the range set.
0 for 0. This means what? I have to
X equal to 0 and y
calculate
equal to
x
0.
equal to
X
0
is 0
and
and y
y
is
equal
0.
to
Y
0.
is equal to 0.
2
Yes.
0.
So if you substitute x equal to 0 and y equal to 0, what you will get? 0 plus 0 divided by 27. So this means
0.
again 0,
0.
right? Everyone is
Yes,
getting?
Yes, sir.
Yes, sir.
This will
Yes,
be
sir.
Yes, sir.
0. Now come to this part. So this is 1, right? So what we have to do here? We have to substitute the value of x as a 1,
1.
1,
y as a 0. Then what
0.
you will get?
1 by 27.
1 by
The 2
27
by
or 2 by
2 by
27?
2 by
2
27.
by 27.
2 by 77.
2
2
by
by
27.
27, right? Now, next is this is 2. So x is taking value 2 and y is
So
taking
4 by 27.
4 by
0.
4 by
27.
27.
Yeah, correct. So it will be 4 by 27. Very good. Now, what is meaning of this one now? Tell me.
Sir,
X
Uh,
1
equal
by
to 1
so
and
27.
y
this
equals to 0.
0, this is 1, this is 0. This means x is
X
taking
equal to
value
0
0
and y equal
and
to
y is
1.
taking
Y is
1.
taking
So
value
this will be
1 by
2 times
27.
0 plus 1 by 27.
Yes,
Yes
sir.
or no? Do let me know if at any step you are not getting. Okay. Now, what if this is 1 in y is taking 1 and x is taking 1? So 2
1 by
into
5.
1 plus
3
1,
by
that is.
27.
3 by 27.
1.
And what about this part? 1 and 2. So this will be 2 times
4 by
2,
20.
4 plus 1, 5 by
5
27.
by 27.
5 by 27.
Right? Everyone is getting this part, right? Now, what about
Yes,
this
sir.
part?
Yes.
0 and 2. Okay, let me show you this part. So this will be 2 by 27.
By 27.
Okay.
Yes.
What about
Yes.
this 1 and 2? 4 by.
26.
And what about last part? 2 2 is 4 plus 2.
4, 6.
6 by 27. Right?
Yes, 6
Now,
by 27.
first of all, just check whether this is valid or not. So all the probabilities are between 0 and 1, right?
Yes.
And can you
Yes, sir.
check whether
Yes, sir.
addition of all these probabilities, one or not?
One.
So
Yes,
it
it is
is.
one.
It is one, right?
It is one.
One.
Yes.
Yes, sir.
Yes, sir.
No. Okay, so you got the idea how you can make the joint PMF table.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes.
So
Sir, can you explain again?
sometimes this joint PMF tables is provided in the question. Sometimes they will provide this kind of function, and then
And
you
we
have
have to
to
make by
correct,
ourselves.
correct, correct, correct. So I just wanted to give flavor of this kind of part.
Sir, can you
Okay, how
explain
to
again this example?
where
So this full example.
yeah where at which point you didn't get?
Sir, 2 by 27, how is it?
Sorry,
Sir, 2 by 27. Second step.
this one. This one you are talking about?
Yes, sir.
Okay. So first of all, just try to understand the meaning of the notation. So what is the meaning of this fxy? So this means I'm saying x is taking value small x and y is taking value small y, right? This is the random variable. This is the one of the possible value. So what is the meaning of first of all, this is x is taking, okay, to getting this value, we need to check what is the possible values. Okay. So x is taking value 1 and y will take value 0. Yes or
Yes,
no?
sir. Yes, sir.
Right? So what you have to do, you have to simply substitute this value and this value here. So if you substitute 1 in the place of x, you will get 2 into 1 plus 0, which is nothing but 2 by 20. Okay?
Okay. Yes, sir.
Understood?
Yes, sir.
Okay. So there are some hand raise. Is there any query? Amrish Kumar, is there any query?
Sir, I will get this PDF as well today.
Yeah, I think you should ask at the end of the session, right? Okay. So let's try to understand the
One
concept. Okay.
one question, sir.
Hmm.
Sir, I am having one doubt, sir.
Mhm.
Sir, is it if what happens if we like can we take this x as in the column vertical and y in the
Yeah,
horizontal?
you can
Will
take.
it be
Not a problem. No, it's not a problem. You can take. It will be just shuffling of this. So it will be something like this. So you will write y equal to y and x equal to x. Not a problem. So thing is that this row will be the this first column,
column?
actually first column.
Okay.
Second row will become as a second column. Okay.
Okay.
Basically, it
This
will
will not
become
a problem.
transpose.
So you can create.
Transpose.
That's not a problem. Okay.
Okay, sir.
Yeah. Okay. Fine. So thing
Thank
is
you, sir.
that okay. Yeah. So everyone is getting the idea. What is the meaning of each entry? Okay. So what
Yes,
is
sir.
what I'm trying to say here? Suppose this is x, this is y. I will write 1 and 2. Suppose this is 1 and this is 2. For example, suppose this is 0 and 2. Okay. So this entry means x will take value 1 and y will take value 0. Right? And this means x equal to 2 and y equal to 0. And this means x equal to 1 and y equal to 2. And this means x equal to 2 and y equal to 2. And these are the joint probabilities. Okay. Is this clear? How we are getting the values?
Yes,
Yes?
sir.
No?
Yes, sir.
Yes, sir.
Okay, great.
It's clear.
Okay, now how many of you can recall we start one course? Why I'm asking, because there is one important thing I will try to relate from there. Okay, maybe let me draw that table. Maybe you can recall. So there was one example, ownership of a phone and gender, right? Female, male. You can
Yes,
maybe
yes,
you can
yes.
recall or no.
Yes.
Let's say
Yes, sir.
there is a
Statement.
ownership of a smartphone.
Week one content,
Okay,
sir.
and there is one.
Yes,
Yeah,
sir.
it's from
Sir.
week 4 actually. No problem. That's not a big issue. So what I'm trying to say here, let me for example, this suppose this female under category male.
Suppose
Okay. So
clear.
for
Sir, your,
ownership, it's a no,
sir,
and
your
yes.
connection is not stable.
Voice is breaking,
So,
sir.
so your voice is breaking. So your voice is
Now
breaking.
is it fine?
Yes,
Yes,
sir.
sir.
Sir,
Now
it
Yes,
is
sir.
Yes, sir.
clear,
Now
but
it's
not.
fine.
okay. Is it okay now?
Yes, sir.
Yes, sir.
Yes.
Yes, yes.
Yes, sir.
Okay. 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 Fine. Okay. Give me a second.
So again, it's breaking.
Okay. So, am I audible now?
Krishna, can you please mute
Yes, sir.
yourself?
Yes, sir.
Okay. So, suppose for female, it was some
Sir,
22. Let's
sir,
say
again it's
some
breaking.
Yes,
Sir,
sir. Your
it's
voice is
fine.
breaking.
again
I
breaking.
think you have internet issue.
Yes, sir.
I I think it is raining, sir.
Yeah,
Not because
actually,
of the rain.
heavy
The
rain
internet
in
issue is
my
there.
college.
I can. Yeah, I can understand.
Yeah. Now
Continue,
is
sir.
it okay? Is it
Yes,
okay?
it is okay.
Is it
Yeah,
fine?
now clear.
Yes, sir, it's
Yeah.
okay.
Oh, great. Yeah. Do let me know
Sir, again
whenever you are
breaking.
facing any kind of difficulty.
Sir,
Okay.
It
again breaking.
sometimes breaks and sometimes it's
I,
fine.
Sir,
it's fine. Yeah, come on.
yes, sir.
Breaks sometimes.
Initially it was
Sir,
fine,
it
then
is
again it
manageable.
breaks.
Please continue.
It's fine. Come on.
Okay. Now is it okay?
You can. Yes,
Is
sir, it
it
is
fine?
okay. Continue, sir.
Sir, little
Okay.
little.
Okay. Okay. So let's say this is some 30%, for example, and some okay, some 30, and let's say what else we can take? Anyone can recall? Okay, okay, let me take some other values. Suppose uh okay, think some other example, maybe that will be better. Some like one example which is related to table part. Okay.
I have the table, sir. Do you want the
So
numbers?
no, number I can take anything. That's not
Sir, your voice is again breaking very badly.
Yes, sir. It was
Sir, it is worsening.
okay. Is this
like, sir, we can't
let
listen to
me
you
1 minute.
carefully.
No, but it's not like continuously breaking. So it's okay. You can continue.
Yeah,
Yes,
it's
sir. You
raining.
can
Yeah,
speak slowly so we can
it's raining, so even sir cannot do
need
anything.
to happen.
Sir, you are not audible now.
Hello. So your voice is not coming. Not audible.
He's not speaking, so he's not audible.
Okay.
Does anybody know if the host disconnects, will the streaming stop?
No, it won't.
So it has nothing to do with the host's connection, right?
No, no. Once the streaming is online, the host does not have any permission to. Once they cancel
Okay.
the meeting, then only this will get disconnected.
Okay.
I think sir is restarting his computer.
Just wait a few minutes. My teacher will come.
Hello. Can you hear me now?
Yes, sir.
Yes, sir. Now it's okay.
Yes, sir. Yes,
See,
sir.
due to weather,
Yes, sir.
so I think there is some network problem in my area. Okay. Okay. Whenever you will face any difficulty, do let me know. Okay. We'll try to fix out.
Yes, sir. I will let you know.
So let me share my screen again. Okay, so I was discussing this part. Okay, suppose there is some values for, let's say, this is some this value for x1, this is for x2, and this is y1 and y2. Okay, some values, random values. Okay, we are not focusing on the values. So what I'm trying to explain here, what if I will ask, what is the probability of being a female? Then what will be your answer?
There is
X
no enough
plus
data.
x1
Female
plus
row.
x2.
Sorry,
X1
The
plus
row
x2.
corresponding to female.
the row corresponding to
Female.
One
Female.
female, right?
female.
And if I will ask what is the probability for male, then
Row
we will
corresponding to male. Zero.
Corresponding to male row.
correct. What if I will ask, suppose you have selected a person and that person says no. I'm not worrying about gender. I'm simply saying that person says no. That means what?
It will be the
So
column.
the column.
This
Column.
one.
Column wise.
Column
Now,
wise.
if suppose you have selected that person and that person says yes,
Second
So it will
column.
be the yes
Yes.
column.
Second
section,
column.
right? Now, so this is something I'm trying to explain. What is the called? So terminology is called uh,
Marginal.
marginal
Yes.
probability mass function. So what is the meaning of marginal actually? So marginal means suppose you are interested in X, for example, then it will give you. I mean, basically you are
The
interested in terms
individual
of
probability.
correct. So probability for individual, uh, individual random variable. Okay. So if you'll see, if I want to write the some definition or some meaning of this marginal actually, so I can simply say, so marginal stands for like let me write the definition. Okay, before that let me try to make one table and then I will try to explain the, I mean I try to relate these things. Okay, so suppose I'm going to take this example. Okay, this very first example, this 0 1 and 2 part. Okay, so I will say, so suppose this is x1 and this is x2. So you can take x and y, that's not a problem. Suppose x1 is taking value 0 and 1 and y is taking, x2 is taking value 0 and 1. Let's say all the corresponding probabilities are 1 by 4, 1 by 4, 1 by 4, 1 by 4. This is joint PMF table. Okay. So what is the meaning of marginal actually? So marginal means what you did here. Suppose I ask marginal for x1. That means what? You have to basically this will be t1 and t2. So this okay. Suppose I was as marginal of or x1. It's not a problem. Suppose 0 and 1. Okay. So marginal, how you can represent the marginal? So this column, okay, this part represents x1 and this part represents x2. Okay, if I will ask suppose fx1 of 0 for example, so what is the meaning of this fx1 of 0? See, if I'm writing fx1 x2 0 comma 0, this means I'm interested in joint probability, right?
Yes, sir.
Okay, if I'm writing fx1 0, that means I'm interested what is the probability that x1 will take value 0. Okay,
Yes, sir.
so if x1 will take value 0, so what is the meaning of when x1 will take value 0?
So the
When
column corresponding
column
to
part,
0.
right? X1 is taking value 0 here, right? Correct?
Yes,
This
sir.
part?
Yes.
That means what? We have to add this part and this part, 1 by 4 and 1 by 4. Would you agree with me?
Yes,
Correct,
sir.
sir.
Yes.
Right. So 1
Yes,
by
sir.
4, 1 by 4, 1 by 4 will be how what? 1 by 2.
1 by 2.
Right? And if I will write, so this will okay. So this means what? Fx1 equal to 0. So what you are doing here? Okay, correct me. I'm doing x1 equal to 0 and x2 equal to 0 plus probability x1 equal to 0 and x2 equal to 1. Yes or no?
Yes, sir.
Yeah,
Yes,
yes.
sir. Yes, sir.
Yes, sir.
Right. So what
Yes.
we are doing, if I'm interested in the marginal, then what we have to do, we have to add for other values of your, another random variable, right? All the values
We
of
are
another
fixing the
random
value
variable.
for one variable, right, sir?
Correct. So let's try to understand another. Suppose I'm writing fx1 of 1. So what is the meaning of fx1 of 1? So I'm saying 1 only, right? I'm not interested in any joint probability. I'm interested in when x1 will take value 1. So 1 means I'm interested in this part.
Yes, sir.
Right?
Yes, sir.
So how when I will get 1 by 4 plus 1 by 4 again 1 by 2. So basically
Yes,
what
sir.
we are doing fx1, that means probability x1 equal to 1, right? So this means what? I'm doing x1 is taking value 1 and x2 is taking value 0, or x1 is taking value 1 and x2 is taking value 1. Okay, these are two possible cases in where I can get x1 equal to 1. Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Right. So this is again 1 by 4 plus 1 by 4, which is 2 by 4, which is again 1 by 2. Right.
So, are we still
Yeah.
assuming that the value of this x1 equal to 0 is still independent of x2 equals to 0, and same for
No,
x2?
forget about this. Okay, forget about this. Suppose you have joined PMF table and I'm asking what is the marginal of this part. Okay.
Okay.
Okay. Okay. Suppose I'm saying for this 0, 0, you have 1 by 4. Forget about whether you got from independence property or not. Okay. Independence and all we'll discuss later. Okay.
Okay.
Okay. So thing is that I have this joint part. I have this joint part. I am interested in what is the probability x1 will take 0. So you have to think when x1 can take value 0. So x1 can take value 0 when x2 is 0, or x1 can take 0 when x2 is 1. All right. Are
Yes,
you
sir.
getting? Everyone is getting?
Sir, can you explain
Yes,
this
sir.
again?
Yes, sir.
Okay,
Yes, sir.
Sir,
let me discuss for the second one. Suppose I'm writing fx20. So what is the meaning of fx20? Fx20 means I'm interested only
First,
when probability x2 will be 0, right?
So
So I'm
the
interested
row
x2,
0.
correct. So when, okay, what are the possible cases when x2 is will take value 0? When,
And
So
1 by
0,
Column.
0 and 0, 1.
right?
Yeah.
Yes,
So
sir.
x2 is taking value 0 when x1 is 0, as well
Yes,
as when x1 is 1. In both
1.
cases x2 is taking value 0.
0.
Correct. That means what? I'm interested. Okay, I have to add this probability or this probability, right? So
Yes, sir.
this will be, so you can see, so I have to, x1 will take value 0 and x2 will take value 0, or x1 will take value 1 and x2 will take value 0, right? So this is again 1 by 4 plus 1 by 4, which is again half. Yes or no?
Yes, sir.
If I will write fx2 1. That means what? Probability x1 will take, sorry, x2 will take value 1. This means what? Probability x1 is taking value 0, x2 will take 1, plus probability x1 will take 1 and x2 will take 1. Again, these are the probability 1 by 4, 1 by 4, which is 1 by 2. Okay, so you can simply see
Yes, sir.
here. Can I write here fx1 of t1? fx1 or I should write here fx2? Correct me.
X1, sir.
fx1.
FX2, sir.
One, sir.
fx2, right?
FX1.
FX2, correct, FX2.
FX2, sir.
FX2, sir.
Because
FX2.
this is the column, sorry, row total, right? It will be half. It will be half, and this is fx1 t1. Okay, because x1 is taking this value, right? You are getting fx1 by this column, right? So, and you can see total probability is 1. Okay, so you can see what is the marginals here. Marginals means you can simply say marginals PMF you got as x1 is taking value 0 and 1, and what is the probabilities for this part? It's 1 by 2, 1 by 2, and x2 is taking value 0 and 1. And what are the respective probabilities for each? It's 1 by 2,
and 1 by 2.
right? Everyone getting the idea? This for marginal
sir.
PMF. Okay, let's try to do for this table. Okay, should I do right here itself, or let me make this table again? Okay.
Yes, sir.
Okay, let me make this table again. Suppose this is x, this is y, and values was 0, 1, 2, 0, 1, 2. Okay, so what are the values?
0. First entry is 0.
0, 2 by 27, 4 by 27, 1, 3, 5, 2, 4, 6. Okay, 0, 2, 4, 1, 3, 5, 2, 4, 6. Okay, so 0, 2, 4. Okay, 1 by 27, 3 by 27, 5 by 27, and 2 by 27, 4 by 27, 6. I think it's correct, right?
Yes, it is.
6, 4, 10, 2, 12,
Yes,
5,
sir.
17, 20, 21. Yeah, correct. So it's a 27 by 27. Okay, let's try to understand here. So what we have to do, if I will ask fx0. So what is the meaning of fx0 means? I'm interested what is probability that x will take value 0. So when x will take value 0, this part, and this part, right? In all these cases, x will take value 0, right?
Yes, sir.
So what we have to do? Okay, let me write
Sir.
the equation first. This means what? X will take value 0 and y can take value 0.
0.
X can take value 0, y can take value 1. X is taking value 0 and y can take value 2. If you see clearly, so I'm interested in this first column. So it's nothing but 2, 1, 3 by 27. So here fx of, you can say t1 or x, that's not a matter here. If I will ask fx of 1, that means what? I'm interested in this column, right? Means fx, when what is the probability x1 will take value 1, that means what? We have to add all these value for this respective column. Yes or no?
Yes.
Yes, sir.
And fx2,
Yes, sir.
15 by 27, right? Similarly, this will be fy of, let's say, y. So this will give you fy0. Fy0 is 6 by 27, and this will be 9 by 27. This will be 12 by 20. So this is what? This is fy of 0. This is fy of 1. This is fy of 2, right? Yes or no? And if you'll add from here all this value and all this value, at the end you will get value 1. So this represents fx of 0. This represents fx of 1, fx of 2. Okay, any doubt here till this point?
No, sir.
No,
No,
sir.
sir.
So if you will see the formal definition of this part, right? This marginal PMF actually. So how I can write? So fxt is nothing but I can say probability x will take value t. Here what we are doing? We are adding all the possible values of x, y, right? So what we have to do? We have to add the values which belongs to range of y, and what we are doing, we are adding the joint PMF, joint probability. Is this clear? Here here t belongs to range of x and t dash belongs to range of y. Is this clear?
Yes, sir.
Yes.
Okay.
Yes, sir.
Yes.
What if I will write fy of t? So that means what? Probability y equal to, let's say, t dash. T dash. That means what? We have to, we have to add all the possible values of x and joint part. Okay. So it will be t dash, sorry, t comma t dash. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Right?
sir. Definitely clear.
Okay. Great. So should we move to the next part if this is okay to all of you?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So okay, please those
So can you please scroll up little bit?
1 second. Okay, first of all, if you any one of you, I mean, if you do not have any doubt, please keep mute yourself. Okay, yes. Where your doubt?
Sir, the summation will explain again.
Yeah. So here, what we are doing, if you see, if I'm interested in probability at x equal to 0, then what you are doing? X equal to 0 is fixed, right? You are
Yes, sir.
summing over the all the possible values of random variable y, right? Okay. So suppose
Yes, sir.
here t belongs to a range of x, which is we have represented as a tx, and t dash is for ty. Then if I am interested to calculate this probability x equal to t, then what I will do, I will add this sum is okay. What we have to do, we have to we have to do sum over the all the possible values of y, and what we are doing, this joint probability we are adding. You are getting here? You can relate this part, right? So here we are summing over with all the different values of y. You can see, correct?
Yes, sir.
Okay. The similar thing we'll do for if we have been asked for fy of t dash. Okay. So here if you see, if I will ask what is the fy0, so what you will do here, if I will ask fy0 means probability y equal to 0, that means what you will do, you can see for this row, you can simply think, right? In this row, 0 is fixed, right? You are going to add for
Yes.
different values of x, right? So x equal to 0 and y equal to 0 plus
Y will
probability
be added.
x equal to 1, y equal to 0 plus probability x equal to 2 and y equal to 0, right? So you can see we are summing over the all the possible values of y, right?
Yes, sir.
Correct? The same thing we have done here in just a notation form. Okay, all right?
All right, sir.
Okay. So next part is called conditional distribution of one random variable given another. Okay. So first we will try to relate. So in case of events, okay, if you have two events A and B, these things we have done in the stats course actually. Yes, Amrish, you have any query?
Sir, I have one doubt, sir.
Mm-hmm.
Sir, in the lecture, sir, there was one statement that sir mentioned that you can go from joint PMF to marginal PMF in unique way, but you cannot go from marginal PMF to joint PMF in unique way. Can you please discuss on this
Correct.
statement?
So unique way means, suppose thing is that if you have been given this joint PMF table, right? Correct.
Yes, sir.
In which lecture sir has mentioned? Can you tell me? I need to
Lecture
cross check once.
1.2, sir.
1.2.
2.
Okay. So is the
Around
schedule in between or something like that?
around 10:06, sir, has discussed this.
Okay, I will cross check. Okay, do not worry. I will cross check and get back to you. Maybe
Okay, sir.
sir is trying to say here. Okay, such let's say you have been given this joint, right? I've been asked fx0, right? Then there is only one way to get this value, right?
Yes.
Correct? If you have been given fx0, then can you find, can you distribute these probabilities in between?
So
No,
this will
sir.
be a difficult task, sir.
Right? I mean see that this part I'm guessing I need to cross check what sir trying to say. Maybe I will cross check and we'll get back to next part. Okay. Hope that this is
Okay.
fine. Okay. Okay.
Okay.
Okay. So in conditional part, if you had two events, right? Maybe we have seen in stats 1 course, if you have two events A and B, okay. Suppose this is events, let's say A, and this is event B. Okay. So what is the probability that A given B? Okay. This is conditional. So what is the meaning here? Okay. So this means, okay. Formula was probability that A intersection B divided by
Divide
probability
by
of
P
B,
of B.
right?
P
From
of
where
B.
we got this formula, let's try to understand. So I'm saying B has already occurred. That means suppose this red region is already occurred, right? Okay. Now forget this formula. Suppose red region is already occurred, then what is the total case here? Red part only. If I will ask what is the probability that A will occur given that this red region, so what is the case? This common part, right?
Yes.
Yes,
Right?
sir. The intersection part.
Intersection part, and we know what is the probability, favorable divided by totals. Then what is the favorable here? Green part.
So the green
Green
part.
part.
And what is
Intersection
the
part.
total here? Red part,
B.
right? So this is
Yes,
something
sir.
we have seen, right? So given probability that A given B is nothing but probability that A intersection B, you can say A and B also, that's not a problem, and divide by probability of B, where probability of B should be greater than 0. Okay. So this is something we have seen in stats 1 course. Yes or no?
Yes,
Yes,
sir.
sir.
Right?
Yes.
Now the similar thing we try to understand when there is some background noise. Can you please mute? I think
Krishna, sir, is constantly
Krishna, could you please
unmuted.
mute?
Krishna.
Okay, thank you. Okay, so similarly, similar concept we will apply for whenever you have two random variable. Okay, suppose I have random variable x. Okay, and for this, suppose range is t. I mean, t is one of the value and range is tx, and another discrete random variable is y. And suppose this is t dash and this is range is ty. Okay, suppose this is information I have. Okay, so what if I will ask probability that x equal to t, okay, given that y equal to t dash, for example. And if you will try to relate with this formula, then what I can get? Probability that intersection part, I mean and part. So I can write probability x equal to t and y equal to t dash. Yes or no? In the numerator.
Yes, sir.
Yes.
In denominator, what I can write? Probability y equal to t dash.
Yes, sir.
Yes or no? Everyone is getting this part? You can
Yes,
relate
Yes,
sir.
sir.
A
Yes, sir.
intersection means I'm saying probability A and B divided by probability that B, right? So here
Probability
probability
B
that
has
X,
occurred.
correct. So you can relate with this. This is as a, this is as a B, and this is as a. If you want to relate with the formula, then you can
Yes, sir.
relate and you can keep in your mind. Okay. Now what is the numerator part? Can I write fxy t comma t dash and
Yes, sir.
denominator part fy of t dash, right?
Yes, sir.
What
Yes.
is this numerator part? This is joint
Joint
Yeah.
PMF
probability
we have
distribution.
seen,
Joint
right?
PMF.
And this is
Marginal.
Marginal
marginal.
PMF.
Marginal PMF.
And we have learned both things how to calculate, right? So if you have been asked conditional probability and let's say, and you have already information about the joint, then you can, and already, I mean, if you have information about joint probability and you have information about marginal, okay, then you can calculate the conditional. Yes or no?
Yes, sir.
Right?
Yes, sir.
And suppose there is a let me interchange. Suppose I'm saying y equal to t dash and x equal to t, then what should I write in the numerator part? What should I write?
Intersection.
So I can write y equal to t dash and x equal to t.
X equal to T.
Denominator part x equal to t.
P of X equal to T.
What is this? This is joint probability. This is marginal. One
Marginal
more thing,
probability.
if you can focus
Marginal.
here, can I write like this? This part if I multiply to left hand side, then can I
Yes,
get
sir, that can
something
be
like
done.
this? Probability of y equal to t dash given that x equal to t into probability of x equal to t equal to probability of x. Let me write like this. So y equal to t dash comma x equal to t. Okay. So if you can focus, and this part I can write like this. Okay. You can interchange actually. That's not a problem. Anyway, you will get the joint probability here for these two values. So you can simply check if you have been given some cases, you will be given conditional and marginal, then you can find the joint probability. Yes or no?
Yes, sir.
This is, I can say, joint probability equal to conditional, okay, into margin.
Marginal.
Okay. Okay. Some rough idea is clear to all of you. Then I will
Yes,
take
sir.
one of the example. Then we will discuss. Okay. Okay. Is it fine to all of you? This example.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay. Let me take one example,
Sure.
and we will try to discuss the part here. Maybe let me take this same example. Again, I have to make a big table. So 012 012 024 135 246. Okay. Suppose I have this table x, y, 0, 1, 2, and this is again 0, 1, 2. Okay, so 0 by 27, 2 by 27, 4 by 27. So 1 by 27, 3 by 27, 5 by 27, 2 by 27, 4 by 27, and 6 by 27. So these were the you know part. So this will represent fy of, let's say, small y. So this small y represents the one of the value, and here capital Y represents the random variable, and this will be fx of x. Okay. Okay. Let me ask the question. You guys will answer automatically. Suppose I'm asking what is the probability that x given that y equal to 0 and x 0. So what is the meaning of this part? This means I'm asking what is the probability that, okay, this y given y equal to 0 is given to us. This is asking for x when x is taking value 0. So this means probability x equal to 0 given that y equal to 0. Are you able to understand this notation part?
Yes,
Yes,
sir.
sir.
Yes,
Right.
sir.
So this will,
Yes,
okay,
sir.
what should I write here? Probability that x equal to 0 and y equal to 0 divide by probability of y equal to 0.
Y equals to 0.
Y
Now,
equal
what
to
is the joint probability x equal to 0 and y equal to 0? This part,
Yes, sir.
right?
0 by
Yes.
27.
0 by
Yes.
27. This is the numerator part. Divide by
27.
probability of y equal to 0 means what? We have
6
to
by
add
27,
this.
sir. 6
So
by
it's a 6
27.
by 27, right? Everyone is getting this probability y equal to 0, right?
Yes,
We
Yeah.
sir.
have to
Yes, sir.
add all the values
Yes, sir.
in this particular row.
Yes, sir.
So this will be 6 divided by 27. Anyway, this will be 0, right? I think
Yes, sir. It will be
Yes,
0.
sir.
it will be 0, right? Now, suppose I'm saying f y given x equal to 1 at 1. So what is the meaning of this notation first of all? So this x equal to 1 is given to us. So this x
Sir,
equal to 1 is
probability of
given to
x
us.
equal to 1 given y equal to 1.
Y is equal to 1.
No. X equal to
Y
1
equal
is
to 1.
given. Y equal to 1 we have
X
to
equal to
find.
1. Yes, yes.
Okay.
Sorry.
Now, so we need to
Excuse me,
find.
sir.
Yes.
Sir, like I'm just not getting the notation part here. After that, I'm
Okay.
understanding the thing,
Okay.
but
Yeah. So
notation
let
of
me
me.
first of all let me explain. So this x equal to 1 is given to us, right? We are asking given that what is f of y given that x equal to 1. So x equal to 1 is given to us. This one is for this y. Means given that x equal to 1, what is the probability that y will take value 1? Fine.
Okay. So like the x is
That's why.
already given, and we have to
Correct.
change
So x equal to
according to
1,
the
x
1.
equal to 1 is given to us. We have to find y equal to 1. Okay. So okay, let me take some. I will take some 2 to 3. Then it will be clear automatically. Okay. So what is this probability y equal to 1, x equal to 1?
Sir,
This
it will
x equal to
be
1 and y equal to
3
1
by
means
27.
this
This
part,
3
right?
by
3 by
27.
27.
Yeah.
So this will be 3 by 27 and
Sir,
x
in
equal
this
to 1.
case, the answer will be 1 by 3, sir.
Yeah, 1 minute. Okay, let me explain. So what is the
3 by
probability x equal to
27.
1? X equal to
No,
1 means I'm interested in this
9
part,
by
right?
20. Yeah.
So it will be
Yeah.
9
9 by
by,
27.
correct? So it will be 9 by 27. So whatever the answer will be. Suppose, let me change a little bit here. Suppose I'm asking fy of x equal to 1 of 2. So what is the meaning of this? X equal to 1 is given. Okay, you can simply write like this. What is the given part?
And
X
y is
equal to
equal
1.
to 2.
Okay, this is the given part. You can say this is the
And y
given
is
part.
equal to 2.
You
y
have been
equals
asked
to 2.
if x equal to 1 is given to you, what is the probability that y will take value 2? Now, is this clear? The notation part,
Yes, sir.
Yes, sir.
right? Then it will become probability y equal to 2 and x equal to 1 divided
1
by x equal to 1.
equal
Probability
to
that x
1.
equal to 1. So, what is the numerator part? Y equal to 2 and x equal to 1. That means this part.
It's a 5 by 27.
Yes or no?
Yes, sir.
So y equal to 2. So y will take value 2 this here and sorry, x is 1,
4
right?
by 27.
Yes, sir. 4 by
Yeah,
4 by
27.
4 by
yeah,
27.
20,
sorry.
4 by
4 by
27.
7.
So I got confused. So here y equal to 2 and x equal to 1. So this part, right? So it will be 4 by 27. And what is the marginal for probability x equal to 1? Again 9 by 27. Is this clear now?
27.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Let me change a bit. Suppose I'm asking fx given y equal to 2 of 1. Okay. So what is the meaning notation meaning of the notation? First of all, what is the given to us? Y equal to 2. First of
Y
all,
is
just
equal to
write y equal to 2.
Y is
Then
equal to
we have
2.
no,
And
we
x
have
is
been
equal
asked
to 1.
probability that
to 1.
correct.
X equal
So
to
this
1.
means
X is equal to
numerator
P
part will
of
be
x
probability x equal to
x
1,
equal to
y equal
1
to 2
and y
divided by
equals to 1,
probability
y
of y
equals
equal
to
to
2.
2.
Y,
So first
y is
thing we have
equal
to find from table what is
to
the probability that x equal to 1 and y equal to 2. So what is the x equal to 1 and y equal to 2?
4 by 27.
4 by
4 by
4 by
20.
27.
27. So this is x equal to 1 and y equal to 2. So it will become 4 by 27, right? So this will become 4 by 27 and divide by probability that y equal to 2. Y equal to 2 means this
12 by
part, right?
12 by
27.
27.
So 12 by 27. Okay. So 12 by 27.
27.
Okay. Is this clear?
Yes, sir.
Yes, sir.
yes, sir.
Yes,
No
sir.
Yes, sir.
Yes, sir.
all
Definitely.
questions, right? Definitely. Okay. Great. Okay. Two examples, if I can recall from the lecture, something called that hook I
Hello,
can
sir.
toss a coin as many times. Yes.
Excuse me, sir. What is the
Yeah.
range
Please.
of x less y equals to 2?
X plus y equal to 2. Sir, x less y equal to 2 means, okay, you will tell me. If I will write x less y equal, it's not slash, it's the given part, first of all. You will tell me what are the possible values yeah, just to get, if I'm saying x, y is given to us as a 2, what is the possible value x can take?
2.
1 to 0, 1 to 2.
0,
0, 1.
No, if I'm saying this
Hey,
part,
what?
I'm asking
Not
the range
audible.
of this.
1, 2.
1 to
Sir, your voice is again breaking.
Sir,
okay, 1 minute.
the screen is not available.
Hello, can you hear me now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Yes.
Okay.
Sir.
Yeah. So question was this part, right? If I'm not mentioning any specific value of x, so if I will write x given y equal to 2, then what are the possible values can be here?
So 0, 1, 2.
0, 1, 2.
X.
0, 1, 2,
0,
right?
1, 2.
Okay, fine.
Yeah.
Okay, so there were two examples, but actually that is important. Let me write and then I will discuss. Okay, so example was it's important. Actually, you can think as a important. Okay, you can keep in your mind actually. So suppose scenario is throw a die, okay, and toss a coin as many times, okay, as the number shown on the die. Okay. Now scenario is clear. Means you are throwing a die, and after that, suppose you are getting 3. Okay. If you are going to throw a die, then what are the possible outcome? Is the 1, 2, 3, 4, 5, 6. All right.
Yes, sir.
Yes, sir.
Yes or no? And scenario is whatever the number you will get, you have to toss a coin as many times, right? Suppose you got 3, then you have to toss the coin 3 times. If you will get 4 after rolling a die, after throwing a die, then you have to toss the coin 4 times.
4
Okay, is it
times.
clear? Okay, this is the
Yes,
scenario.
sir.
So suppose you are going to define random variable x as a, I mean your random variable x be the no, number shown on the die. Okay, and suppose I'm saying let y be the number of hits. Okay, uh, this is the scenario. Okay, so suppose I'm question is what is the joint PMF of x and y, right? Till now we have seen the table form, right? How will you proceed in this case actually? Okay, so we are going to use the property, right? We have seen this property, right? See, if we have seen this property, right? How I can find the joint? That means conditional is given to us and marginal is given to us. Yes or no?
Yes.
Yes, sir.
Right.
Yes, sir.
So we have seen the part joint equal to conditional probability into marginal. So what was the case? Joint means probability. Let's say x is taking value t, y is taking value t dash. So this means probability y equal to t dash given that x equal to t into probability x equal to t. Okay, just let me know whether I can write this equation or not, because in the here I can write this part or not. X equal to t given that y equal to t dash into probability y equal to t dash.
Yes, sir.
Yes or no?
Yes, sir.
Everyone is
Yes.
getting these two equations.
Yes.
yes, sir.
Okay.
No,
Now,
sir. Wait.
yeah,
Did you change x is equals to t to y is equals to t dash?
yeah. This part I have changed.
Okay,
So
okay,
the
okay.
thing
Yeah,
is,
yeah, yeah, yeah. Okay, got it, got it, got it.
got it. So thing is that if you will apply this conditional probability formula, right? Probability, let's say,
Yes, yes. I didn't realize. Yeah.
okay.
Sir, explain me again.
So this is the joint part divided by marginal, right? So if you will multiply this part,
Yes,
you
sir.
will get this joint probability, right? If you will do in reverse
Yes, sir.
order,
Yes.
let's say I'm saying probability x equal to t, given that y equal to t dash, then what you will get? This joint probability divided by probability that y equal to t dash, right? Because of this,
Yes, sir. Yes, sir.
now if you multiply left hand side, you will get this part. Okay, so this joint probability
Okay.
you can get in both ways. Okay.
Hmm.
Now,
Yes, sir.
so why I have written these two equations? It will be helpful here because you have been asked joint probability, right? But we do not. So what is the possibilities here? Maybe I can use this conditional part and this marginal part, right? So thing is that if you see what is what random variable x represents there, number shown on the die. If number shown on the die, then it will be uniform. Can I say it's a discrete uniform, and it will take value 1, 2, 3, 4, 5, and 6? Yes or no?
Okay. Yes.
Yes, sir.
Right?
Hello, sir. Hello.
Yes. Yeah.
Yeah, sir. My question is, sir, week zero Python in a probability. How to understand, sir? Please.
Sorry. Week 0.
My week zero part two.
Huh?
Week zero part two. Python in probability. How to understand? Please tell me.
Python
Week
part.
zero, I think.
Yeah.
Python
Week
part
zero
you are
part
talking
two.
about.
Yeah, Python part.
Okay, so we
Please
can
talking
discuss
about
in
shortly.
okay. Those are things. First of all, those are things a bit extra. How to do the things in uh, collab notebook using the Python and all. Do not worry about those things. It is going to come in exam and all. Okay, those things are extra.
Yeah,
How
please,
to
But
because
necessary.
this concept is not clear. So please, I am not again. So
see.
please tell me shortly.
Prakash, week 0 is just a revision of stats 1 content and one step ahead. Okay, one step ahead of stats 1 content. So you can watch later
Yeah, but
also. That's not
Python in yeah, but Python in probability I am not understood this concept. So shortly and fastly video tell me because I
no
am not.
Python probability. What do you mean by Python probability?
So I guess
Yeah,
he's
you.
saying that how to define that, and that will be clear when you study the whole Python. Now till December we study Python, and then afterwards it will
Correct,
already be clear
Prakash.
with
So do
the
not
Sir,
worry if you are
sir,
talking about
there.
one second. So if I'm not wrong, so Prakash, do not worry about Python part. Those are things are extra. Okay, how to do the probability things, how to perform the statistic things in Python. Do not worry about those things. First of all, you should be clear with your concepts. Okay, try to understand the theoretical part. Try to solve some questions. Okay, try to solve more problems. Once you will be clear with your concept, then you can automatically do the coding part. Okay, first of all. Second thing, do not worry about the coding. It is not going to come in your stage 2 exam. That is just sir has introduced just to get give you just about flavor about how to perform those things in Python and Colab notebook. Okay, those things will help you in extra activities. So those things we can discuss the later. Okay, I think we
Yeah,
should
yeah,
first
yeah,
focus here in
yeah,
theoretical part.
yeah.
Okay,
Okay, understood. But these things in use in future probability parts. So
correct.
I can understand.
So that's that thing we can discuss later. Okay, first of all we should focus here content of
Yes,
the
sir.
this
Continue,
all.
sir. Continue.
Okay, so here
Continue.
can I say this x follows uniform distribution one which is taking value 1, 2, 3, 4, 5, 6? Yes or no? Because it's a die and
Yes,
all the
sir.
probability for each value is 1/6. Yes or no? So that means I can say fxt or
Yes.
probability will take any value from 1 to 6. It's a 1/6. Here t can take any value, right? 1, 2, 3 up to 6. Yes or no? So
Yes.
far
Yes,
so
yes,
clear,
yes,
right?
sir.
So you can
Yes, sir.
you can
Yes,
no
sir.
you can get an idea here. You have been given the marginal, right? You got the marginal. Means you this part you got, right? Yes or no?
Yes.
Now, so thing is that what is the condition? If you are getting let's say 3, then you have to toss the coin 3 times, and then y represents the number of heads. So can I say y given x equal to t? That means what? I will try to explain. Okay, first of all, let me write. If I'm saying y given x equal to 1 means what? Means you roll a die and you got 1, right? Once you got 1, you are going to toss a coin 1 time, right? Yes or no? That can be head or tail. Correct?
Yes.
Yes, sir.
Yes, sir.
What is the meaning of if I will say okay, so this is the given part, right? Only then okay, that is the scenario. First you have to throw a die, then you have to toss a coin as many times as the number shown. So first it is given to us. You have to throw a die. So suppose I throw a die, I got x equal to 2. That means what? Can I say y given x equal to 2 means what? I am going to toss the coin how many times? 2 times, right? Then
2
what is the
times.
possible
2
Yes,
times.
sir.
number of heads I can get? Number of possible heads I can get 0
One
head,
head, 0, 1, 2.
2.
One
Here
head,
in
two
this
head.
case I can get 0 head, 1 head, right? If I will write y given x equal to 3, this means what? I have to
Sir,
toss
I
the
have
coin
to toss the coin 3 times.
3 times, and I what is the possible number of heads? I can get 0
Sir,
head,
here the head
1
will
head,
be 0,
2
1,
head,
2, 3. 0, 1, 2,
right?
3. Yes, sir.
This means what? Can I say this y given x equal to t will follow binomial, right? Distribution
Distribution.
with value t comma half stands because it's a coin. I'm talking
The
about
probability of
unbiased.
getting head.
I'm talking about fair coin, right? This is not a biased coin. So this t means okay. Normally we have seen binomial n comma p. N represents the number of trials. So here t represents number of trials. Trials means whatever the value you will get. Suppose you will get x equal to 2. You have to toss the coin 2 times. Then it will be binomial 2 comma half. Y given x equal to 3, it will be 3 comma half. Is this clear?
Yes, sir.
Right? If this is the
Yes,
part, then what will be the probability mass function for this part? If I'm saying f y given x equal to t, let's say t dash, what should I write here? Just focus this part. This is going to follow by
probability of y equals to t1,
no, no,
comma
no,
x
sir.
equals to t.
Given x equal to t.
First of all, this part follows the binomial distribution, right? What is the PMF of binomial distribution? NCX, right? P raised power x, 1 minus p raised power n minus x, right? What is the n here? Instead of n, I have t, right? Correct? T,
Correct.
C, T dash, right? Because T dash is going to take this value, right? T dash means y represent number of head here. Okay? Again, it will be 1 by 2 raised power t dash and 1 minus 1 by 2 raised power how much? T minus t dash,
Leader.
right? So it will be tc t dash 1 by 2 raised power t dash, and again it will be 1 by 2 raised power t minus t dash, and t dash will get cancelled out. It will be t dash, and it will be half raised power t. So now you can see you got the conditional part and you had the marginal part. Then I can find the joint probability. Yes or no? So joint fxy t comma t dash means probability that x equal to t, y equal to t dash means what? Probability that y equal to t dash given that x equal to t into probability that x equal to t. So this part, okay, so it will be tc t dash into half raised power t, and for what is the probability that x equal to take value t? 1 by 6, right? Okay, can any one of you can you tell me the range of y given x equal to t?
1, 2, 3, 4, 5, 6.
6.
0 to
1 to 6.
1 to t, right? I'm talking about t, not 6. Okay.
Oh, sorry, sorry.
Okay. So whatever the x value number will take t, you have to do. Okay. Is this clear? Actually,
Yes, sir.
scenario.
Sir, in that NCX, how did that x become t dash?
No, no. Actually, this was the so x is one of the value for whatever the random variable will take, right? So here, instead of x, it is taking t dash. That's all.
But sir, t dash is the value that y is taking.
Y will take, correct. See, what is the PMF of binomial? If I will write x equal to NCX, right? So n represent the number of trials, right? So here t represent the number of trials. Trials means whatever the values x will take, you have to toss the coin. That is number of trials, right?
Right.
X represent the number of success, right? So, means number of hits. I'm interested here, right? So here y will take value t dash. So that's why it's a t dash. That's all.
Okay, yeah.
Clear? Okay, so there is another example. If I'm not sure how many of you covered. I
Excuse me,
think in
can you tell
yeah.
me why did you assume that as a binomial distribution for that particular order of probabilities? Like,
No, it will follow the binomial, right? It is follow. It satisfies all the properties of binomial, right? In binomial, what is the case? For each trial, you should get either success or failure, right?
right,
Okay. So here, if you suppose you will toss the coin 2 times, right? Okay. So either for each time you will get head or tail, and here I'm interested in head, so it will be success, right?
right,
Tail is failure. First thing. Second thing, all trials are independent or not?
correct.
It's a
Yes.
independent, right? So it follows the property of binomial. That's why we have written as a binomial. Okay. It's not like I wrote randomly. Okay.
Okay.
Clear? Yeah. So there is one more derivation if you want. I don't think we should do the derivation. If you are interested, we can do in next session. Uh, or else because that will take some time. Okay. Would you like to do me that derivation? Maybe.
Yes, sir. Yes, sir. Do, sir.
Okay. You haven't watched, or you just simply want. Because I think after this, we have to discuss joint PMF of when we have more than 2 random. Okay, let me do quickly. Okay, if you are not getting, try to rewatch again. So suppose I'm saying there is a capital N, which is follows Poisson distribution with parameter lambda. Okay, so there is okay. If one more thing is just a request to all of you, if you do not have anything, right? So you should please keep mute yourself. Okay, so Pranjali Prakash is asking why you use binomial. I think I have answered for this question, right? Because it satisfies all the properties of binomial distribution. Okay, IID property, and for each trial we have success or failure. So what I'm saying, this given capital N equal to small n. Okay, so thing is, suppose you have to toss a fair coin. Okay, small n times. Okay, this is the scenario. This is one of the scenario, and denote the number of hits. Suppose I'm going to take a random variable x, and I'm going to denote number of hits, whatever the number of hits we have obtained, and I'm going to denote that by random variable x. Okay. So question is, what is the distribution of x? Okay. So we will try to use the concept whatever we have learned so far. Okay. So case is capital N follows Poisson lambda. Sorry, Poisson with parameter lambda. If this is the case, what is the PMF for if I'm going to write capital X follows Poisson parameter lambda? Okay. Okay. So what is the PMF for this part? What is the PMF of Poisson random variable? Anyone can recall? It's a e raised
So
power
e to the
minus
power
lambda.
minus lambda,
Lambda is
lambda to
for
the power
x.
x
So instead of x, I
divided
have
by
small
x
n, right?
x factorial
So
n
instead of
factorial.
x, I have n factorial. So what is the range?
Yes, sir. Yes.
It will take 1, 2, up to so on, right? Now, if
Hmm.
okay, now this is the case. Can you tell me if n equal to n is given to me? Now you will tell me if n equal to n is given to me, and what is the x represents? First of all, then after that we have to toss a coin small n times and denote the number of heads obtained by x. So can I say x given n equal to n? This will follow binomial or not? Just think and tell me whether I'm right or not.
Yes, sir. Binomial.
Yes.
It will be binomial, right? So this is
Right.
says whatever
Yes,
the
sir.
value of small n, let's say small n is 3. That means I have to toss a fair coin 3 times, right? If this is the case,
Three
it will
times.
follow automatically 3. It will be small n, okay? And with
Yes,
success
sir.
probability half. So far, so good,
Half. Yes, sir.
right? Now, if this is the case, so tell me what is the like probability mass function for this part? And we know this part follows the binomial, then what it will be? It will become NCK, right? Instead of
Yes,
x,
sir.
I have k, right? And
Yes,
half
sir.
raised power k and half raised power n minus k.
N minus k.
Right. And what is the value of
Yes,
k?
sir.
K will be can take any value from 0 to n. Right.
N. Yes, sir. Yes, sir.
Right.
Yes, sir.
Now, so if this is the case, it will be n c k and half raised power k, and this will become n. Right. K will get
Yes,
cancelled
sir.
out.
Yes,
So
sir.
this is the part. Now question is, here we have been asked the marginal, right? You can see we have been asked the distribution of x only. Yes or no?
Yes, sir. Yes, sir.
And if you have
That
been
means
asked the
marginal.
marginal, and we have seen one property, what was that? Joint equal to conditional into marginal,
Into
right?
marginal.
To
Yes,
get the
sir.
marginal, what we have to do? We have to divide joint probability divide by
Joined by
conditional,
conditional.
right?
Yes, sir.
So to get this part, first of all, we have to see here, we have the conditional probability, right?
Yes, sir.
See, we have seen, right? We have seen joint probability equal to conditional
Conditional into
into
marginal.
marginal, right? And to get the marginal, because question is about what is the
Condition
distribution of
divide
x.
joint
So it
divide by
will be
conditional.
joint divide by conditional, right? So
Yes.
we have been given conditional, right? So what we have to calculate? We have to calculate the joint
The
probability,
joint distribution.
right? So what is the joint distribution? We have been given one random variable capital N as a Poisson, and okay, another is okay. So joint probability I can denote as a f x n, right? Because I'm interested here, and x is taking value k, and capital N is taking value small n. Yes or no?
Yes, sir. Yes, sir.
Right? This is clear to all of you. What I'm trying to
Yes, sir.
say.
Yes,
Okay.
sir.
Now this is case. Now we have seen also joint equal to what? Conditional into marginal. Can I write this
Marginal.
joint probability as f x given n equal to n k into uh, f n of n or not? Means what I'm trying to say here, x equal to k,
Joint equal
n equal
to.
to n. Can I write probability x equal
Yes,
to
sir.
k?
Marginal into conditional.
Yeah, one second, one second. X equal to k, n equal to n, given that into probability sorry, n equal to n. Can I write this part? Everyone is getting this part.
Yes, sir.
Yes.
I'm
Yes, sir.
Yes, sir.
just right. Can I write this part?
Yes, sir.
And from the above equation, you can see I have information about this random variable, correct? Which is this part. And I have information about this random variable, which is Poisson random variable. Yes or no?
Yes.
Yes,
Right.
sir.
Yes, sir.
So what I can write this part. See, I'm doing the derivation. Maybe it might be boring for to all of you, but just let's try to get from where it is coming. Okay. So it will be half raised power n. What is this part? E raised power minus lambda. Lambda raised power n divided by n factorial.
Yes, sir.
All right.
Yes, sir. Yes,
This
sir.
is okay to all of you.
Yes, sir.
Now,
Yes, sir.
Yes, sir.
Yes, sir.
the thing is, if I want to calculate, I have to calculate marginal, right? This means probability x equal to k, right? Then what I will do, I will add this joint probability through all the possible values of n. Yes or
Yes,
no?
sir.
Are you getting? See, this joint is given. This marginal we have to calculate. What is the distribution of x? That is the that is our main question, right? So can I write? We have to add summation of this joint probability throughout the all the range of n or not? Everyone is getting this part. Is this clear?
Yes,
Yes,
sir.
sir.
Right?
Yes, sir.
Okay. Can you tell me here? Yeah.
Sir, your PC is dying, sir. Can you connect it?
Oh, thanks. Give me 1 minute. Give me 1 minute. Yeah. Thank you. Okay. Subankar, please. Okay. So everyone is getting this part, right? If I want to get this marginal, I have to add the, uh, I mean, all the possible values for the another random variable. Yes or no? Right? So one more thing.
Sir,
Can you?
can
Yes.
you
Yeah.
comment
Yeah.
this again, please? Explain this
Okay.
again.
So this is marginal part, right?
Yeah.
Right? To calculate the margin, what we did in the previous questions. Yeah, can you recall? We added we add
Joint
the
by
all the
conditional.
Yeah.
no, 1 second, 1 second. We have added all the joint probability for different all the possible values of another random variable, right? You can see for probability x equal to 0, what we have done here, x equal to 0 is fixed, right? We have added the joint probability for different values of another random variable, right?
Yeah. Yeah. Yes.
Right, here you can see probability x equal to t means we have to do the summation over all the possible values for random variable y. Okay, the similar thing we have to do here. So here question is we have to calculate this probability x equal to k. This is marginal part. Then what I'm going to do, I'm going to add all the possible values of random variable
Yeah.
capital N.
And
Here capital N is the one random variable. Now is this fine?
yeah. Yeah. Got it.
Okay. Now, one more thing I want to ask, maybe you can answer. So, will it be valid if I will write n equal to 0 to infinity, or n can take any value also?
I did
Can
not
you think a
understand
bit?
what
Yeah,
I
so
did not
question is, okay,
understand.
so n is taking value 0 to infinity, right? And x is taking value k, right? So is this right? All right, if n equal to 0, okay, what will be probability if you'll write n equal to 0 here? Probability x equal to k and n equal to 0. Can you think? In this case, you can relate with this part, this conditional part. N equal to 0 means what? You have to toss coin 0 times. That
Yes.
doesn't seem okay, right?
Yes.
Okay.
Right,
So
sir.
can I say n equal to k to infinity? Now you can think,
Yes.
Yes, sir.
right? Yes or no?
Right, sir.
Right? Okay, because
Yes,
before
sir.
k, if n is less than k, all the probability will become 0. Now what we have to do, we have this part, we have calculated this part, we have to simply substitute here and we have to try to identify what is the possible values, I mean, what will be the distribution of your random variable x. So here I have written nck, okay, I'm just substituting this value, half raised power n, e raised power minus lambda, lambda raised power n divided by n factorial, right? This is something we have done. I mean, I have simply substituted from here. Is this clear? Yes?
Yes,
No?
sir.
Okay. Now, so can I take e raised power minus lambda outside? Okay.
Yes.
Also, can I factor this as n factorial divided by k factorial into n minus k factorial? Right? Yes or no? And I have 1 upon 2 raised power n lambda raised power n divided by n factorial. This is something we have. Yes?
Right,
No?
sir.
Now, this we have to do simple mathematics here. Okay, just we have to be careful a little bit here. So can I write n equal to k to infinity? That is something we have already given. Okay, so this lambda is for n, this is k factorial into n minus k factorial. Okay, can I write this 2 raised power n as a 2 raised power k into 2 raised power n minus k? Yes, no?
Yes, sir.
Correct? And this lambda raised power n, can I write this as a lambda raised power k into lambda raised power n minus k?
Oh, yes.
Right, sir.
I can write,
Yes,
right?
sir.
Now, if this is the case, I can take outside this part, right? So e raised power minus lambda and lambda raised power k, okay, divide by this part, the k factorial 2 raised power k, I can take outside or not, right? Because this summation is over only for n, right?
Yes.
Yes,
So
sir.
we
Yes.
can write lambda raised power n minus k divide by n minus k factorial into 2 raised power n minus k.
Yes, sir.
Any doubt till now?
No, sir.
No, sir.
No doubt, sir.
Okay.
Combine lambda and
Now, now this is the case e raised power minus lambda. Can I write this as a lambda by 2 raised power k divided by k factorial outside the
Yes.
summation? Inside the summation,
Yes,
can
sir.
I write lambda by 2 raised power n minus k divided by n minus k factorial?
Yeah, factor.
Yes,
So
sir.
far, so good.
Yes, sir.
So far, so good. Okay.
Yes.
Now,
Yes, sir.
there is something expansion of e raised power x. Maybe you can relate. That is called, if I'm writing summation r equal to 0 to infinity. Okay. And x raised power r divided by r factorial. This is nothing but e raised power x. Right. So here n minus k okay, if I have written n equal to k, then can I write n equal to k as n minus k equal to 0 to infinity?
Yes, sir.
yes,
Right?
yes.
Yes,
Now
sir.
you can relate this n minus k as a r. This is the case. What will be the summation part? Summation part will be what?
E power
R equal
E
to
raised
0 to
E power
infinity
lambda by 2.
to the
Yes.
power R.
into
That's all.
lambda by 2.
Correct?
Yeah.
Is this fine? Is this clear to all of you? Okay.
Yes, sir.
Now, so this is something we can see. So it is for minus lambda plus lambda by 2. It will become minus lambda plus lambda by 2. It will become minus lambda by 2, right? Yes or no? So it
Yes,
will
sir.
become
Yes, sir.
e raised power minus lambda by 2 raised power k divided by k factorial. Then what is this? What is the distribution of your x equal to k? What is the can you tell me? It's a Poisson distribution
Poisson
with
distribution.
parameter lambda by
K.
2. No, not k. K is the one of the value.
Yes.
Okay, fine. Is this clear?
Yes,
Okay.
sir.
Yes.
All right. So let's okay. So
Sir,
far,
could you please? No, no, okay.
yeah. Go ahead.
No, okay. Just like in the end, can you please show again that question? Not now. Continue.
Okay. So this is the I mean we are done with this part. Okay. So if there is any scenario n equal to n is 0, which is for
Voice is breaking, sir.
Sir, your voice is breaking, sir.
Hello, sir.
His connection is lost. Can't use.
Am I audible now?
Your voice
Yes,
is
sir.
still breaking, sir.
Hello. Okay. Is it still the same or it's manageable?
Now manageable, sir.
Now it is okay.
All right.
It's okay now.
So it's manageable now.
Okay. Okay, great. Thank you. Okay, so we have seen the joint PMF, right, for two random variable. Okay. So what was that? I mean, suppose x is and one of the random variable, and it possible value is, let's say t, or let's for simplicity, let's say t1, and range is tx. Okay. And x2 is t2, and x2 is another random variable and possible values of, let's say t2 and the range is tx2. Okay, so we have seen for two random variable, that means x equal to, if I will write fx1 x2 t1 comma t2, that means what? This means probability x1 will take value t1 and x2 will take value t2, right?
Right, sir.
Yes or no?
Yes,
This
sir.
was two random variable. What if you have more than two random variable? More than two random variable. Suppose I have three random variable. Then I will write like this: fx1, x2, x3. So t1, t2, t3. So this means t1 is one of the value which is taken by x1. T2 is one of the value which is taken by x2. T3 is one of the value which is taken by x3, right? Random variable x3. So this means x1 will take value t1 and x2 will take value t2 and x3 will take value t3. Okay, what if you have four random variable? So similarly we can generalize. Okay, so generalization is nothing but, if you have n random variable fx1 x2 up to xn, you can write t1 t2 up to tn. So this means what? I will write probability that x1 equal to t1, x2 equal to t2 up to, I will write xn equal to tn. Is this clear? Where ti is
Yes.
nothing but
Yes, sir.
range of each xi random variable. Okay, is this fine? Is this fine to all of you?
Yes, sir.
Yes.
Oh,
Yes.
yes, it is
Yes,
fine.
sir.
Yeah, let me take one very simple example, then we'll try to take some difficult question. Suppose scenario is, previously I to toss a coin twice. Now suppose I'm going to toss a fair coin thrice. Okay, okay, this is the case. Then you can define simply, let each xi will take value 1 when, if the ith toss is head, right? And is it will take value 0 if ith toss is tail. Okay, what is the possible values I can take? 1, 2, 3. Correct?
Yes.
So this means what? Okay, if you can think a bit, so this means x1 can take value 1, 0, x2 can take value 1,
1-0.
0, x3 can take value 1 and 0. Basically you can simply say tx1 is what?
So it's breaking.
0 and 1. Tx2 is what? 0 and 1. Tx3 is what? 0 and 1. Am I audible clearly now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So whenever you have been given more than two random variable, right? So it's good to go with the table part. So table part means what? Try to make all the possible combinations. It may take some minute, but thing is that your answer will be correct. So what I mean here, so t1, let's say t1, t2, t3. Just be with me for a second. It will be clear in a minute. So I'm going to draw joint PMF table. So t1 comma t2 comma t3. Okay. So what we will do here? So what is first possibility is what? 0 0 0, right? Yes or no?
Yes.
Yes,
See,
sir.
in
Yes,
case
sir.
of this part, in case of two random variable, we made simply table, right? Correct? We made table, right? All the possible values, right? 0 1 2 0 1 2. Then what are the possible values? If you will do the similar way, right? If you will do in similar way, what I'm going to do here, let's say this is t1, this is t2. So what are the possible cases here? T1 can take 0 and y can take 0 1 2 0 0, right? This is part 0 0 0 0
Yes,
0
sir.
1 0 2, right? Similarly 1 0 1 1 1 2. Are you getting? So similarly this will be 1 0 1 1 1 2 2 0 2 1 2 2, and you can find the joint probability from here also. Are you getting? Right? So
Yes,
it will
sir.
be 1 by 4 1 by 4, not 1 by 4. Actually these are the different things: 0 by 27, 2 by 27, and all the values we can write. Yes or no? The similar
Yes,
way
sir.
we will do for whenever we have more than two random variables, right? Then because it's a bit tough to make the table in that case. So we can write simply all the possible values. Here it's a 0, 0, 0. And what else? It can be 0, 0, 1, right?
Yes, sir.
And next it can be 0, 1,
One
0.
zero.
I think we are, and another it can be 0, 1, 1, right?
Yeah.
I think we are done with this 0 case, right? Similarly, it can be 1, 1. We can do like this: 1, 1, 0, 0. Then 1,
101.
1, and
110.
1, 1, 0, and
191.
1, 1, 1. So these are the possible values. Your you can simply think it's a total 8, right? 8
Yes.
possibility, right?
Eight.
Because 2 is for this, 2 is for this, 2 is for this, right? So 2 into 2 into 2. So you can cross check whether you got total 8 possible outcomes or not. Are you getting my point?
Yes, sir.
Getting,
Yes.
sir.
Yes,
Okay.
sir.
Now, so what
Yes.
will the probability for this part, since you are going to toss a coin, right? So you are tossing a coin and it's a fair coin. So for each value, it will be 1 by 2, 1 by 2, 1 by 2. So I can write simply 1 by
1 by
8.
8.
For this part, again 1 by 8. For this part, again 1 by 8. For this part, 1 by 8, 1 by 8. Because it's a fair coins, then probability of getting head and tail will be half. So you can simply check 8 by 8 is nothing but 1. Is this clear?
Yes.
Yes, sir.
Okay.
It's clear.
All right. Okay, so suppose we have seen the marginals part also, right? In case of
Yes.
whenever you join
Sir,
means
your voice is
suppose
breaking.
you did
Sir, your voice is
two
breaking. Sir, it's not clear. Your voice is breaking, sir.
one. Can you hear me now clearly?
Your voice is audible, sir, clearly.
Yes, sir.
Yes.
Yes, sir.
Clear? Okay.
Sir, we have math class at 8 p.m.
Okay. Okay. Anyway, I think almost done. I will continue for some 10 minutes more. Then okay, you can join. Okay. I think I'm done with. Just give me 10 minutes. Okay. So we discussed how to find the marginal, right? So what we did, we added all the possible values of y. I mean, we added the joint probability, right? Or for all the possible values of y, right? If you have three random variables, then how you can proceed? Okay, let's try to understand with this example actually. Okay, so what I mean, suppose I've been asked. Sorry. Suppose question is fx1 of 0. That means what? Means for x1 0 will be fixed. You have to add all the possible other possible values. This means what? 0 is fixed, right? Others can change, right?
The values of
Yes,
other
sir.
variables are changing.
Correct. We have to sum over all the possible values of other two random variables. Yes or no? Only then I
Yes,
can
sir.
find fx1 0. Are you getting?
Yes, sir.
So
Yes, sir.
fx1 0 means what? I'm saying probability of x1 equal to 0. So probability of x1 equal to 0 means what? I have to see x1 will 0, x2 will 0, x3 will 0, right? This is the one of the case. You can think like this: when x1 is taking value 0, this part and this part, right? Or in this case x1 is taking value 0, or in this case x1 is taking value 0, or in this case x1 is taking value 0. Yes or no?
Yes, sir.
Are you getting? Everyone is getting my point. So we have to add all
Yes.
these probability of all these possible cases, right? So it will be 1 by 8, 1 by 8, 1 by 8, which is 4 by 8, which is nothing but half.
Yes, sir.
Yes, no. Are you
Correct, sir.
getting right what I'm trying to say? Actually, this will be summation of probability x1 equal to 0, x2 equal to 0, x3 can change, or probability x1 equal to 0, x2 can take 1, x3 can take 0, or probability x1 will be 0, x2 will be 1, and x3 will be 1. That is something. Okay, if this is the case, suppose I'm asking what is the probability x2 will be take value 0, x2 will take 0. That means what? Probability that x1 can take 0, x2 will be 0. Let me fix. Okay.
Sir, is this
X2 will
same
0.
as, sir?
Yes.
Is this same as marginal probability?
Yeah, this is the marginal probability.
Okay.
Okay, marginal means you are interested probability of a, I mean PMF of a single random variable. If you have been given the joint, you are interested for a single. Okay, so here what is the possible cases? Okay, here x3 can be 0, x1 can change, right? So again, it can be x1 can be 0, x2 is again 0, x3 can take value 1. Yes or no?
Yes, sir.
And
Sir,
x1 can take 1.
Sir, so
Yeah,
basically
yeah.
you are saying that we will fix the value for this x2, that is 0, and rest will be the possible combination of
Correct,
x1 and
correct,
x3.
correct. That's what we have to calculate. Means basically you can think this as maybe if you can recall from the law of total probability. Okay, so if you are saying this part, right, I'm saying probability at a marginal part, probability at x equal. Okay, you can think like this. Suppose I'm saying what is the probability x1 equal to 1. Okay, so we have to think, see, when x1 can take value 1, in this case x1 is taking value 1, right? Yes or no? Or in this case x1 is taking value 1,
Yes, sir.
or in this case x1 is taking value 1, or in this case x1 is taking value 1, right? So we have to
Right.
add all this probability, joint probability, and then we will get the marginal of that random variable. Is this clear?
Yes,
Yes,
sir.
sir.
Yes, no?
Yes, sir.
Okay, so similarly we can do the conditional part. Okay, conditional part, since we have done for two random variables, so we can relate with in a similar way. So since if, okay, what we did, suppose probability x equal to t, given that y equal to t, how we did? Probability x equal to t, joint divided by marginal of probability y equal to t. All right. So if you have been given three random variables, right? So if I ask, let's say you have been asked, suppose I'm saying x1 equal to t1, given that let's say x2. I mean we are going, let's say x1, x2, x3, and x2 equal to t2, comma x3 equal to y3. So what does this mean? This means this part is given to us, right?
Yes, sir.
Are you getting? So it has been given x2 equal to t2 and x3 equal to t3 is given to us, right? So how I can write? In the numerator part, it will be joint, right? Yes or no?
Yes, sir.
Fixing the values of two variables, right?
Correct. I will get back to you 1 minute. So in the numerator, okay, numerator part is okay or not? Suppose you have three random variables.
Yes, sir. Yes, numerator is okay.
Numerator is okay. In denominator, this is part x2 equal to t2 and x3 equal to
X3
t3.
equal to T3.
Now,
Yes,
how you can find, suppose this information is given to you, you can calculate or not?
yes, sir.
Calculate,
We
sir.
Yes
can
or no?
Yes,
check.
sir.
Yeah.
So, sir, I have one question.
Hmm.
Like here, we will consider all the possible this like value of T2 and T3.
In the denominator part, means you are
Yeah, yeah,
interested
yes.
in joint probability of x2 and x3.
Okay.
Okay, understood.
And we will
So
sum.
basically,
Oh, yes.
yeah, yeah. One more thing. Let me try to explain. One more thing we have seen, right? So joint equal to what? Okay, let me write this part. This part. Okay, this is the case. Can I write this part as a probability x equal to t, comma y equal to t dash. Okay, sorry, it should it should be t dash. No one corrected. No worries. So can I write this as a probability that x equal to t, given that y equal to t dash, into probability of y equal to t dash? Yes or no? What is this? This is joint equal to conditional into marginal, right?
Margin.
Okay. Now, if you
Right.
have three random variables, then how? So can I write f x1, x2, x3, let's say t1, t2, T3, okay, how you can proceed actually. So I'm trying to explain here. Can I write this as a, let's say fx3 of T3? Okay, if you are getting confusion with this part, let me write like that. Okay, so let me write in that way. Suppose if I'm writing probability that x1 equal to t1, x2 equal to t2, if I have to calculate this part, how I can proceed?
So your
Can I
voice is
write?
breaking,
You
sir.
can think like this. So can I write probability x? Now is this okay or still breaking?
Sir, we have math
Still
class
breaking, sir. I
starting
can manage.
related.
So I can manage,
Can we
sir.
leave it,
Okay.
bro?
Can I write this
Sir,
probability x3 equal to t3? Okay. Yes or no?
sir,
If
we have
this is the
math class,
case,
sir.
can I write probability?
Yes, sir.
Yeah, I will take from some 5 minutes. Okay, it's
The
already
class is
recorded.
started.
Then you can watch later also. Krishna, you can, if you want, you can leave. You can attend the my session. I will take 5 minutes. Okay, it's already recorded. Then you can watch it later also.
So we will
Okay,
get a
so can
recorded
I write?
in YouTube only, right? Hello, sir. So your voice is not coming,
So
sir.
can
So your voice is not coming.
It is
Yes, sir, your
recorded.
voice is not
In
coming,
fact,
sir.
you can
So you are not audible right now.
Nishikesh. It is on YouTube. There is channel. That's too. You can find this
Yes,
video
yes,
there.
Sir, huge
yes.
lag.
That's true, I think. Hello, sir. Sir, are you there, sir?
can you hear me now?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
sir.
Yes, sir.
Yeah. So okay, this is just a last concept. Okay, then I think if we can close after this. Okay, can I write this x2 equal to t2? Already we have calculated. Then I can write x equal to t3
Sir, voice is
simply.
breaking.
So it's very much breaking the
Sir,
voice.
nothing is hard, sir, from your side.
Yes, sir. It's just breaking.
Now is it okay?
It's heavily breaking.
Yes, sir. Unable
No,
to
sir, it is
manage.
not
It's
okay.
fine now.
Sir, I think you should stop today, sir. Your network is very disrupting.
Now can you hear me now?
Sir, we are unable to manage with the voice breaking issue.
Sometimes your voice is
Sir, I
breaking,
think you
sir,
should
as well as
stop
your
today,
the
sir.
screen becomes thick.
I think, sir, your audio and video is breaking.
Both
Both
is
have
lagging
issues.
today.
I think it's network problem.
Yes, it is obviously the network problem. Sir is writing from Sat's end, but it is not reflected on our end.
Hello, hello. Can you hear me now?
Yes, sir.
Yeah, actually, I think there is lot of network issue. Okay, so we will continue the last concept in the next session. I think. I hope that is fine.
Yes, sir. Yes, sir.
Okay, yeah. Thanks, thanks. I hope whatever we have discussed till now is clear to all of you. Okay, yes, yes. Someone has raised hand. If my voice is okay, then you can ask.
Sir, how many lectures have been planned for each week?
It's two sessions, including, sorry, excluding TS session. Okay, there will be some TS sessions also. Okay,
Okay,
so you
okay.
can check your calendar. Okay, so two sessions will be taken by us, and others will be. Yes,
Okay,
what
okay.
your doubt?
Thank you, sir.
Thank you. Yes, Pyari Singh. Is there any query?
Yeah, it's similar, sir. So for the
Yeah.
solve with us session, what will be happening?
Like in solve with the session, what we are doing, we have prepared some slides. We will come up with those slides. In that slides there will be some questions. Okay, we will discuss those questions in the session. Actually, you have to solve those questions during the session itself. Let's say for question number one, as per the level of questions, we will assign some 2 or 3 minutes, and then you have to solve that questions. Okay, in the during the session itself, and after that we will discuss the solution part.
Okay.
Similar thing we did in stats one course actually.
Okay. I actually
Oh,
never attended live sessions.
okay, no problem, no problem. That's not
Okay.
okay. Okay, okay, okay. Then
Can you share the PDF?
okay, so I will share with the support team. They will upload by tomorrow. Actually, they can upload. It's already 8. I don't think they will be active, but yeah, by
Sir,
tomorrow
why
it
it
will
will be
be
uploaded?
under supplementary content. You can find the PDF. Okay.
Okay, okay,
Okay, okay,
thanks.
sir.
Oh, oh, okay, okay. Thanks all, and sorry about the network issue. Okay, I think I will discuss the last topic in the next session. Okay.
Yeah. Thank you, sir.
Okay.
Okay.
Yes, sir.
Thank you, sir.
Thanks.
Thank
Thank you,
you.
sir.
Thank you. Bye.